Hi guys, today very important topic is OSI layers or ISO layers. OSI means Open Systems Interconnection. ISO means International Organization for Standardization. There are 7 OSI and ISO layers. From top to bottom, transmit data. From bottom to top, receive data. First one, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Let's start with physical layer. First one, physical layer. The physical layer is responsible for the physical transmission of raw bits over the communication channel. It defines the electrical, mechanical, and procedural aspects of the physical connection between devices. Examples include cables, connectors, network interface, cards, NICs, and signaling. OSI model two types: media layers, host layer. Media layers are physical layer, data link layer, network layer. Host layers are transport layer, session layer, presentation layer, application layer. Physical layer, the data will be in bits. Data link layer, the data will be in frames. Network layer, the data will be in packets. Transport layer, the data will be in segments. Session layer and presentation layer and application layer, the data will be in data only. So let's discuss data link layer. Data link layer. The data link layer is responsible for reliable and error-free data transfer between directly connected network nodes. It provides framing, error detection, and flow control mechanisms to ensure the integrity of data transmission. Examples include Internet, Ethernet, Wi-Fi, and PPP, point-to-point protocol. 1 to 4 are transport service, 5 to 7 are upper layer. Here we can compare with OSI and TCP layers. TCP means Transmission Control Protocol. IP means Internet Protocol. In OSI, physical layer and data link layer. In TCP, we can call as network access. So, two OSI layers, it become one network access layer. In OSI network layer, we can call as internet layer in TCP. Transport layer, same for both. Session, presentation, application, in it become only one application layer in TCP. You can see in the diagram. Fourth one, transport layer. The transport layer is responsible for end-to-end communication between host systems. It ensures reliable and efficient data transfer, segmenting large data into smaller packets, and providing errors recovery and flow control. Examples include TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Session layer. The session layer establishes, manages, and terminates communication sessions between applications on different hosts. It provides synchronization and dialog control mechanisms, allowing applications to establish and maintain connections. Examples include session management protocols like NetBIOS, Network Basic Input Output System, and RPC protocols. RPC means Remote remote procedure call. As we discussed, physical layer transmits raw bit stream over the physical medium. Data link layer defines the format of data on the network. Network layer decides which physical path the data will take. Transport layer transmits data using transmission protocols including TCP and UDP. Session layer maintains connections and it responsible for controlling ports and sessions. Okay, now let's continue with presentation layer. Sixth one, presentation layer. The presentation layer is responsible for data representation, encryption, and compression. It ensures that data from the application layer of one system can be understood by the application layer of another system. Examples include data encryption, compression algorithms, and ASCII American Standard Code for information interchange. Seventh one, application layer. The application layer provides services directly to the end user applications. It enables communication between networked applications, including the file transfer, email, web browsing, and remote access. Examples include HTTP, Hypertext Transfer Protocol, SMTP, Simple Mail Transfer Protocol, and FTP, File Transfer Protocol. In TCP, three layers are not present. Those are physical, session, presentation layers. So we completed all 7 layers. Here just I am explaining TCP and IP protocols. Transmission Control Protocol (TCP). TCP is responsible for establishing and maintaining a reliable and error-free connection between two devices over a network. It breaks the data into packets and ensures that they are transmitted in the correct order and without errors. TCP also handles flow control and congestion control to manage the efficient transmission of data. IP Internet Protocol. IP is responsible for addressing and routing packets of data across the network. It assigns a unique IP address to each device connected to the network, allowing them to send and receive data. IP determines the best path of data transmission and ensures that the packets are delivered to the intended destination. TCP and IP provides a layered approach to network communication with multiple protocols operating at different layers. The protocol stack includes other protocols such as UDP, User Datagram Protocol, for lightweight, unreliable data transmission, ICMP, Internet Control Message Protocol, for network troubleshooting and error reporting and others. TCP and IP is the foundation of the Internet and is widely used in local area networks (LAN), widely area networks (WAN), and other networks to enable reliable and efficient communication between devices. It enables various applications and services such as web browsing, email, file transfer, and streaming to function over the internet. Thanks for watching. Please subscribe and share.